The following content has been provided by RWTH Aachen University.
So, all right, good morning. Welcome to Designing Interactive Systems 2. Today we will continue with the post-desktop systems, have a look at sort of more a description of mobile apps in general, then have a look at iOS, Android, and then sort of extend our scope beyond the smartphones to TVs and sort of give an outlook to what is coming there despite phones. So last week we already mentioned that, actually 2 weeks ago, right? That mobile device characteristics look like this. Like we typically have a compact screen size, which means there's only one screen at a time. And of course, that as there's not much room for to display stuff, also the on-screen help is minimal. Also things like, say, a label under a button, which you typically find under a desktop system, is not prominently used in mobile systems. And of course, there's the restrictive memory management and so on, because actually sort of history repeats itself all over again, and especially at the beginning of mobile phones, there wasn't much RAM there, which also meant that if you only have very few memory, both in RAM and then in hard disk space, basically, there's also not room for swapping. So mobile systems still do not support memory swapping, which means that if an app is killed, it's immediately killed. And of course, this means that we sort of have to inform the app or give it some opportunity to know that it might die soon. We also had a look at the 10 golden rules. I will skip them and instead continue now with slide 7. So yeah, mobile OSs, app-centric environments, one app per task, and sandboxing. Basically introduced by mobile systems, now commonly found also on desktop systems because of the security enhancements. But yeah, of course, this sort of limits the scope of what you can see. If you think about a few years ago, it wasn't even possible to just access a file like on iOS that is stored inside an app. An app would have to create some user interface to show the user this data and then sort of allow him to copy it, say, to another app. Then with the introduction of the Files app and a few years ago, and I think in fall, a new downloads folder finally, things sort of became better. You sort of have the opportunity to change data between different apps, still in a limited fashion. So when we are designing a mobile app, of course, it has to be obvious how to use it. Think about the context. People are using this app on the go. They don't have much time. They want to process the information that you display quickly. And as typically there is no culture that aligns information from bottom to top, it's actually a good idea to sort information from top to bottom, so that you sort of show the most important things first and then structure your UI vertically. Then of course alignment is scanning, and so on. Also think about where the fingers of your users are. There are two aspects. The upper part is typically not covered by a finger, as the user is holding his hand like this. Of course, this is for a right-handed person. But also that the reachable targets are somewhere there. So what we see here, like in the calculator app of iOS, that there's not really any content in this area that cannot be reached anyways comfortably with one hand. And we also see that the result is also sitting on top, because this is an area that is typically not covered by the user's hands. Yeah, of course, things come along with this, provide fingertip-sized targets. Nobody wants to spend time like being able to precisely click on one digit of this calculator interface. And what's more, there's this prepared for changes in text size. What this means is mobile phones are typically something that people want to use easily, and this means they are on the go, and if your eyesight is no longer that great, you don't really want to wear, so take out your glasses, wear them, like if you're only good at seeing in the long range but not in the short range, you wouldn't really wear glasses for like going along the street. But then if you have to use your phone, you would suddenly need your glasses and then get them out your bag and put them on. Nobody wants to do this. So actually there are a lot of settings to sort of stretch the UI, make things larger, make the text size larger, and of course these settings can occur while your app is running. So think about that. Your layout might break while the user changes the text size, the font size for your labels as a global setting. Then of course we said limited screen size, not much on-screen help. This means there are not really a lot of on-screen signifiers what and where to do things. It has to be sort of intuitive, and saying that, I know this is hard. I mean, especially with the flat design, if you just have a colorful text and this means this is a button, it's sometimes hard to tell what is a button and what is just some other colorful text. One important aspect is to remember is that actually the interaction patterns, especially in types of gestures, vary between different operating systems. Like say on iOS, a typical gesture to go back to the previous screen is by swiping from the left corner or edge of the device into the screen. So as it sort of moves the content back to the way it stacks content. So if you think about if you have one screen and you enter the next one, it typically comes in from the right side, and if we want to get rid of it again, we swipe it to the left so that it reveals the previous contents again. This is something that you typically wouldn't find on Android, for instance. Or like Android typically edits a list if you sort of hold some item and then you're switching into this edit mode of a table. Again, something that would never happen on iOS. This typically has a dedicated button at the top right corner. And if you sort of introduce a cross-platform system that doesn't really consider these unique characteristics of the platform, your interaction might feel very decoupled from the rest of the system, which is probably not what you want to achieve. What are actually the mobile application styles that we find? And we can see that we can actually divide apps into 3 different categories. The first thing are utility applications. You see, utility applications are things that sort of provide you or help you with a very simple task. There's minimal user input, and there is sort of focus on nice visual details, often accompanied with some custom UI that doesn't really look like the default, I say, settings app look, but instead sort of it visualizes things more interestingly. Like the compass has this custom compass here animated. The stocks app, of course, shows bars and sort of plays with different fonts and colors. Or like this app, it's called the Elements. It sort of gives you an overview of all the elements in a periodic system, and there are even like small 3D objects that you can rotate and have a look like. In this case, this is a titanium wheel, or you would see a gold nugget or something like this. So you see customized, visually attractive UIs that sort of enhance the displayed information, and there is no notion of files. People just, they open the app, oh, I check my stocks, it's done. It's not like, oh yeah, I open the stocks app and then I open my stocks database file and then I see, oh yeah, the Apple stock is currently at, I don't know, $216. Probably not the way that users interact with this. It's more like I open the Stocks app and boom, the results are there. For productivity applications, things are different, like the calendar or the Notes app or Microsoft Excel. You see, what happens is that actually we introduce some navigational hierarchies here. They all have some back button there because obviously there was already a previous state. That for Excel, which file am I actually going to open? Or for notes, my list of notes. For the calendar, sort of skip between different levels of whether I'm showing a year, a month, a week, so the scoping. So hierarchical information structure is very important. And you see that I'm also working with files in some extent. I mean, obviously for the Excel example, I opened my Excel spreadsheet, right? For the nodes, it's sort of still a very own database. It's the nodes database, basically, that's stored in iCloud. But still, I'm sort of working with a file, like if you interpret a node as a file. So you see that productivity apps are very focused on the task. This visual glitter that we had in the utility apps went away. Most of the stuff is white and grayish. Buttons have their default look, like you see here today, calendars inbox or the done button. Even for Excel, buttons are no longer fancy. So you see, apps use typically the standard UI elements. It looks like the settings app. There's still some room for branding, like in the case of Excel, we want to have a green bar somewhere on top, at least Microsoft wanted to have it. But yeah, so as the user is here focused on the task, actually there's not really a need to provide the visual glare there. Instead, a focused UI that is sort of receipts and has only text or not that colorful interfaces is helpful there. And also use the standard gestures for this. I mean, if you're editing creating, say, a text processing application, and you want to enter the user to enter the text, like with the keyboard, then the question is, how should the selection gesture be done? Or how should the text formatting work? Will you create something known, or do you take that what's already given by the US? Typically the second one, so that your application is immediately sort of useful. And of course, this means that this is an issue for cross-platform apps because actually these systems vary between the different operating systems. Like even simple things like text selection works quite differently on iOS and Android. So the last category of applications we can have a look at are immersive applications. Probably most important, games. So you see, we have some full screen UIs there, typically no split screen, also visually attractive, and of course focused on the content. Usually, like games, even hide the status bar. I mean, in the case for Pokemon Go, it was probably good to still show the user the battery indicator, because this is like a problem at playing this game. But in the end, even Google Maps, again, an immersive application, it's about the visuals, all the status bar stuff disappears there. What we also see, like in an immersive app, like a game, is the UI is highly customized. Like the buttons, the Pokeball button in Pokemon Go, it's not a button that says Pokeballs. Instead, it's sort of an image that doesn't really look like an iOS button. Think about the iOS button was like this here. Instead, it's sort of customized, visualized. There are even new icons for like running away. You see here in Monument Valley, there's also another button that sort of gives you or provides you back to the home menu. Still, it sort of looks different. So you see custom navigational methods, typically custom widgets, custom gestures, like spin the Pokeball and flick it up, something that you wouldn't use in iOS probably, but for a game this makes very much sense. So how do we implement these applications? Let's first have a look at iOS. And of course, as with all systems, we start with the history, but in a very condensed fashion. So the first iPhone actually came out in 2007, and what it introduced was multi-touch. Like this system that nowadays is very clear to us, that we interact with our touchscreens by using multiple fingers instead of just a single one, was sort of invented with the iPhone. Actually, they proposed that it was very patented. In the end, sort of every other system implemented it as well. But as the first iPhone, you couldn't really do much with it. There were your stock applications, and that's it. There was no app store. You couldn't install other apps. Actually, the way Apple originally thought people would install apps was that they developed websites. So you could attach websites to your home screen. Actually, you can still do this. And then there were things that were called web apps. So apps that sort of try to mimic parts of the iPhone user interface just by using CSS and showing it full screen. Like the very first web apps for the iPhone, I remember, were things like a solitaire game that you could then basically play in Safari. And because Safari knew, oh yeah, this is a web app, it would just hide the URL bar on top of the screen so that you sort of saw the card game there. So yeah, and then in 2008, the App Store came, because obviously web apps alone are not sufficient to do a lot of things, because you need access to hardware, to the GPS sensor, to the camera, and so on. And all these new possibilities basically then arose when the App Store came out in 2008. Then 2 years later, the iPad came, new category, tablets. Also, of course, meaning that app developers now had to sort of create two different UIs. Using a phone UI on a tablet is typically not a good idea. You have more screen real estate, and you shouldn't just stretch contents, but instead sort of use it. I mean, the reason why we removed on-screen help on smartphones was because the screen was too small. But now, with the tablet and the larger screen, we can sort of reintroduce features there that we know from desktop systems. Then to 2011, leap into voice sort of agents with Siri. Nowadays, sometimes it's lagging behind Alexa, as people say, also because of the privacy concerns Apple still has with sort of spying on the user's voice data, because they don't want to do this, and hence they can't learn from this. But yeah, Siri, interesting also in types of interaction. When it came out, it was so interesting for people to just tell the system something and something happens, like, oh yeah, joke, weather, whatever. So obviously, multimodal interaction is appealing for users. I think we're slowly getting a point where they actually become useful as home assistants, but still Siri, 2011. So a few years ago. Then leap into wearables with the Apple Watch in 2014 and 2015, 3D touch, new dimension of touch. How can we increase the expressiveness of touch? And Apple's approach was to say, yeah, we could also measure the force that a user uses to push against the button. Now, 2019, Apple thinks about removing this feature again because the sensor is too expensive, and also because they probably didn't find out what you really do with this. And this actually leads us to a very interesting problem now. So with this home screen layout, there are typically two things you can do with them. You can hold or tap on an app icon to open the app, obviously, and you can hold the icon to move into an edit mode, and you can rearrange them or delete them. Now, when they wanted to integrate shortcuts there, actually the initial idea was good, to say, okay, tapping and holding are already taken. So what can we do else? And then was like, okay, we can press against an icon to show a shortcut menu there. Of course, this has some issues in terms of visibility. You actually don't know what can you force press and what not. But maybe that's the reason why it wasn't widely adapted. So now, 2019, Apple thinks like, oh yeah, iOS 13, let's get rid of 3D Touch again while maintaining the same functionality. And this is also not great. So I think the way they currently expect it to work is like, you can tap, it opens the app. You can hold the app, I mean no 3D touch. And if you lift your finger, I think after 200 milliseconds, but before 800 milliseconds, then the shortcuts will appear. And if you lift your finger afterwards, you'll be in edit mode. And of course, I mean, basic DIS1 knowledge, this is not a good idea. So while I was working now with the system, I actually realized most of the time it does the other thing than I actually wanted to do, because, well, we as humans are not super trained between differentiating between a touch that lasts 500 milliseconds versus one that lasts 700 milliseconds. At least I'm not really capable of doing this. Yeah.
It's a bit off topic, but do you know how they want to do it on Mac? Because you have the force touch on there too. So
I think for the Mac it still remains so far. But again, in the Mac, I think the only use case for using the force currently is in QuickTime and iTunes, that you can force press and then skip faster or skim faster through your video, or
to adjust your click pressure that you have to, because it's quite dynamic, so you can just adapt it, and that's quite the only use case I see.
Yeah. So I guess I hope it lasts with the Mac. I don't know. I think for the Mac it's even more important because the trackpads are solid state. They don't physically move. They just imitate a click, which sort of means if they remove the clicking capability, we would be at the cheap 90s, basically Windows trackpads that don't do anything when you touch them. I don't think they will move to this, but at least for the phone, they are removing it. And probably this is also because the software was just not really good enough in showing people what they could do with 3D Touch. So yeah, also 2015 iPad Pro, split screen mode, finally multiple applications at once. This all sort of turned into iPadOS like this year. We can now have, I think, 4 applications opened at once, like one main app, an additional app, a slide over app, still another video running in the picture-in-picture mode. On a small iPad, this is already like a lot. It means like your interfaces become even smaller than an iPhone. This is typically not what you sort of want to do, like type on a tiny keyboard if you have a large tablet. So yeah, this is always this trade-off, and as they are probably, hopefully not going to introduce Windows on a touch user interface. I mean like desktop Windows, not Microsoft Windows. This is probably like the peak of full screen touch interfaces that we can reach in terms of number of apps that are running at a time. So you remember the architecture of macOS. There's this core system based on BSD, and then there are Apple services and media on top, and then the Cocoa framework that especially contains AppKit to create your applications. Now, when Steve Jobs announced the iPhone, he said like, yeah, and iPhone is running OS 10. And this is sort of true because actually all of these parts, they still live here on the phone as well. The only layer that was changed was obviously the top one, the one that contains the UITK because this is sort of specific to a platform. So you see, if you're running an app like on an iPhone or Mac, you can sort of access the same CoreOS, you can access the same media features, your UITK changes. But of course, there are a few years between the Cocoa and Cocoa Touch framework. So you find some other difference there. Of course, the first thing is there's the different event handling. Suddenly, views support multiple inputs. I mean, there is multi-touch. There can be multiple fingers occurring in a view and out of them. And of course, there had to be sort of a new event chain. Remember, this was also a reason for the Qt people to come up with Qt Quick, because Qt widgets was also not capable of doing multiple inputs in one widget at the same time. Then, of course, other things like do not even let developers show or create a main menu for an application. We don't want to have a main menu in an app. Also, I think in the Android world, these small context menus that sometimes appear, they also wanted to get rid of these additional menus that you had. I think if you're not using a Samsung phone, on the right button, right, showed some small sheet menu in the early days of Android, and then this slowly faded away because these menus really are not fun to use in a mobile app. You don't know what is going to be in the menu, so you click on the menu and then you realize, oh yeah, the feature I wanted to have wasn't in the menu anyways. So no main menus. But then, of course, a few years later, more modern framework, and it's finally possible to use target action with more than one item. So if you have a button, you can connect it to multiple methods and they will all be called instead of just the one that you had in macOS. And then, of course, limitations they had to introduce, because the original iPhone, of course, wasn't really fast, and also there wasn't that much working memory. I think 256 megabytes of memory. So originally only RGB color space, of course, which was a huge drawback because, you know, Mac, beloved product in the design and visual designer community, that has a huge code base for working with colors in different color spaces, not only RGB, but SymYK and HSV and all this stuff, and mapping between them. This is all missing on iOS, I think, even today. Of course, there are a few more changes, so changes in foundation. They got rid of Cocoa bindings and of distributed objects. Cocoa bindings, I don't really know why they removed it. No distributed objects. I can see this. So as a reminder, distributed objects on the Mac sort of allow you to split up your application across multiple devices on one network, and then the code base, your code base, can call classes or objects that are living on some other computer without writing network code, because actually the objects can communicate or exchange methods across the network, which is of course clear that this is technically possible, because again, the Objective-C resolves the methods that are called at runtime, and if there is no thing on your computer that is handling a selector, why not shout it out to the network and see if some other computer responds to this selector? So yeah, this is distributed objects. For phones probably, as they are mobile, not that needed, so they removed them as well. And then, of course, lastly, some new frameworks to interact with the phone hardware. Macs didn't have like an accelerometer, or Macs don't really have to rotate their screen when you're rotating your laptop. Typically, you don't put your laptop in a 90-degree angle, right? So this is what's happened there. So as we said, touch input, how can you handle it? And the first thing that was only available at the beginning were like overriding these touches methods for touches began, moved, ended, cancelled, and so on. And you see, they're sort of similar to what you've seen on the Mac with key down or mouse pressed, mouse dragged, and so on, because the framework, of course, should appear familiar to the developers there. You see, what now happens as a parameter is that you receive a set of touches, and this sort of makes sense. Is there an order in the touches that you have on screen? How can you sort of say, oh yeah, the user is putting 5 fingers on the device, which is number 1. So of course it's a set. Actually, you can sort of keep reference to these touches objects. So a touch object lives for as long the user touches the finger on the screen, and then once the user lifts it, the touch object dies. So what you typically do is, if you're just interested in some position, like say a very first touch, you can just tell the set, give me any touch, and then we can have a look at touch location in, say in this case, self. So this method has probably been implemented in a view. Yep.
What do we do in case of like sequential touches that have to be recognized as a sequence?
What do you...
Like, if we have a set of gestures that does something, in a game or in anything, what do we do then? Do we store it in a list or something?
Yeah, okay, so what do you do to detect gestures? Yeah, this is a good question. Basically, you have to remember or keep references into this touch set. So you remember touches from this set, store them in a local variable, and of course also remember, so maybe it's more like a dictionary what you say, and then you remember its point. So of course then you once the user does this with, what, I don't know, 60 Hertz with a screen refresh rate, after a second you have like an array that contains dictionaries, like there are 60 items in your array, and in this dictionary you know this touch was at that point, at point in time, at point 50-50 in view coordinate space. And then you would sort of write your code that has a look at this. So of course this can become, it's clear? Yeah. So this can become messy if you have all this in your view code, because there are sometimes very distinct things you want to detect, like maybe a swipe or the user doing a circle, and you don't want to couple everything into one gigantic piece of code. So that's why a few years after the first iPhone, I think it was around iOS 5, I think, gesture recognizers appeared, and they are basically things that have their own touches began, moved, and ended touches lifecycle methods inside their implementation of the gesture recognizer. So there are default gesture recognizers for, say, pinching, rotating, and double tapping, single tapping, swiping, and so on. But you can implement your custom ones. And what then happens is you attach a gesture recognizer to some view. And every time a touch event occurs in the view, this can sort of pipe these events also to the gesture recognizer, which can then, before actually the touches are handled here, sort of process the information and see what it can do. You can sort of define the behavior that your gesture recognizer has by having a look at other properties there, like delays touches began, delays touches ended, and so on, cancels touches once it recorded something, and so on. So this is sort of a very interesting approach to modularly define the behavior of multi-touch interfaces. This slide shouldn't be there. I only have this for formatting. So, yeah, what are the typical gestures that you see? Single finger gestures like tap to just open something, double tap, typically used on iOS to zoom in or zoom out at a specific point, like in a map or a website, and then touch and hold to sort of open the menu in editable text or to edit your home screen layout and so on. Then, of course, gestures that need a larger footprint there, like dragging, so for, say, scrolling, flicking to switch between pages. Actually, a flick is just a faster drag and then, of course, swiping. So swiping is something that you typically see occurring starting at the edge of a screen. So if you're in a table and you swipe from the right side all the way to the left, you delete the item in the table. Then, of course, gestures that include even more fingers, pinching, rotating, very similar, I think also very straightforward. And yeah, shaking the device as the default gesture for doing undo. I still don't know why they did it. I guess the idea isn't that bad. Something bad happens. You're obsessed. You're like, no, stupid phone, why did you do this? You shake it, and it prompts you, oh yeah, should I undo the action? So probably conceptually there is some sense. It's weird. If you have a 13-inch iPad and you shake the device to undo deleting your mail, doesn't feel good. That's the reason why in the fall with iPadOS they replaced this gesture on the iPad with a 3-finger swipe. So no more shaking tablets. But you see, these things are already very straightforward, also interacting with 2 fingers, quite clear, like pinching. This is also already not that intuitive, but we're very used to it. But at this point, we're introducing even more gestures, 3-finger, 4-finger, 5-finger gestures. People don't really have a conceptual model for this. So you have to be very, if things are defined already in some consistent format for this platform, use these default gestures. Don't come up with, oh yeah, I'm developing Word 2.0 and now I'm neither going to do undo with shaking nor with the 3-finger swipe, but instead people have to do a back arrow gesture, something like this. You could implement that, not a good idea. So gestures, careful. I think this is also the reason why they are also so slowly integrated, and then every once in a while, in a few years, a new gesture appears so that people actually have time to learn and adapt to them. Now, as I said, there is no memory swapping on mobile devices. So actually we need a new mechanism to provide the app more information in which state it currently is. Like if you developed an app, say for a desktop system in Java or whatever. You implemented your window and it's living there and the user probably has it open. And then you minimize the window and forget about it for a day or 2 or 3 or a week. And then you can open it again and the window is still there. What happens in the background is, if your operating system needed the memory of your app, it would have just cleaned it from the working memory, from the RAM, and swapped it on the hard drive. But we said mobile systems don't have a lot of space that you want to fill with swap files. So actually, mobile systems said, okay, we just kill it. I mean, the first iPhone, 16 gigabytes of memory. Think about this. 2 occupied by the operating system. I think there was even a version at the beginning sold with only 8 gigabytes. There's not a lot of room. So you don't want to use swap files there. But now, if there are no swap files, your application has to care about whether it's going to die or not. Your Java app on the desktop, it doesn't matter. If you open it up after 3 weeks again, if there was some contents typed into a text field, it's still there. For an iOS app, this meant, oh yeah, it's gone now. So lifecycle models are something that you would see on all like these systems, like on iOS, Android, even on the Universal Windows apps, because of the Windows 10 phones that were originally planned. And they sort of notify the app, in this case sort of the app delegate, when the app transitions to a state. So what we see our app is not running. And then the user taps on it and it switches into this inactive mode. This is just a transient state, which sort of means user interface cannot react to inputs yet because the app is sort of launching and event added into the event route, but then it's basically immediately switches to active, which means your app is running in the foreground. Now what happens is the user presses the home button and we sort of switch into the background mode. This is sort of the last transition that we know as an app that happens. So now the app is in the background, and if the OS now decides it needs more memory, it will just terminate you and wipe you from the memory. And you won't be called to between background and suspended. So this means there is this new call, like in the app delegate, application did move to background, and you know, oh yeah, the form that the user currently typed in, probably remember this, or remember the complete state, save it into some plist file or whatever, so that you remember it, and then you can sort of launch your application again in the way that the user left it last time when he entered the background mode, despite that that it might be completely terminated in between. So what are sort of these things that you find in your project when you develop an iOS app, like an info property list file? We've already seen this on the Mac. That sort of contains the capabilities that the devices require, sort of signing information about the developer and so on. Then this app delegate as a last resort for app handling and also taking care of your app lifecycle. Usually don't really implement a lot of code in there, but it sort of always exists. Then you have your view controllers. There's typically in a storyboard and a nib file that defines the UI, and then of course some backend code behind it. And then lastly, some entitlements, which is sort of, if you're requiring a capability that is security relevant, that is sort of restricted, or if you want to access a cloud service from iCloud, you need an entitlement. So this is like Apple telling you, oh yeah, you can use this feature if you want it, and this is basically your private API key to this. So maybe one last word about the view controllers. View controllers in iOS are again a little different to what you see on Android, because they don't really have to occupy the complete screen. I mean, of course, Android 4 also introduced fragments, and then you can also combine these things, but it's not the same. Like the bar that is sitting on top of basically every iOS app that tells you the title of your current screen, this is the same object across all screens of your app, and it's not recreated every time as it is on Android, because actually iOS loves to nest view controllers in different matters. And of course, you will see this in the assignment sheet when you exchange the view controllers that are in your split controller. So we also mentioned auto layout in the Mac lecture. And of course, the same auto layout system is available on iOS. Actually, auto layout first appeared on iOS. But we will see that over the time there was a very important addition to auto layout on iOS that we don't have on the Mac. So of course the question is, how can we create an interface that works on all different aspect ratios, device sizes, and so on, like on a phone, on a tablet that's way larger, I want to display things differently, like we have these tab bars for different screens of our app. These are small touch targets. On the tablet, it would be better if they are larger. So here the touch targets are larger. Again, difference. How does the system determine when it should display something like what? And this is something that I already teased in the lab. It's obviously size classes. And these size classes can then be used to infer how your user interface is going to look like. So what we see here is like an iPhone that is regular sized, and then an iPhone Max, which is a phablet, and then some small iPad mini so that it still fits on the screen. So if we have a look at the size classes, we will see that for both phones, the width is described as compact when they are in portrait orientation, whereas the iPad is called regular size class. Actually, there are only two size classes available in an enum for every direction, and this means either it is regular or it is compact. And if you have a regular interface, this means, oh yeah, just show whatever you want, there's enough space. And compact means basically careful, there might not be enough room, think about a more condensed fashion to show your user interface. For the height, this is sort of similar, but as these devices are quite long, they all have a regular height. So this also means if you're running an app now in portrait mode, your app only supports being used in this orientation, and you still want to introduce a difference between like a phone and a tablet, you can only do this by accessing the width size class and have a look whether you're regular or compact. For the actually landscape mode, things are a little more obvious. So you see now that the regular iPhone that people have has now a compact height, because now think about, these are just a few centimeters. There's no longer really enough room to have these large navigation bar titles on top of them. And what we also see, again, is that there's now suddenly a similarity between the iPhone Max, which means the phablet, and the tablet, because they both have a regular width, which means now that if you have a split view controller, which you typically see like on an iPad in all orientations, like a main view and some detailed sides, then you would always see this on the iPad, and the phablet, like the iPhone Max or Plus, has this additional advantage of showing this split view screen then again when it is in landscape format. So of course there are a lot of more frameworks if you can have a look at it. This is just some excerpt. You see like app extensions become more and more important to sort of increase the collaboration between different apps. Handoff as a tool to send a current activity that is going on your phone over to your Mac and then continue on, say, the same website or document. Multitasking, notifications, AirPlay as a way to remotely stream content to your TV, MapKit and MusicKit, and of course WebKit, which is sort of the internet or browser engine that's running behind Safari or also, say, Android, right? And then app services like HealthKit, CloudKit, and so on. Quite new machine learning becomes more and more important, SiriKit, and of course a lot of things for games like Game Center, like their achievement system, SceneKit as a 3D graphics framework, even with an own editor, and SpriteKit as a 2D graphics game engine thingy, again with an own editor, or Metal, which is basically Vulkan, just different for high performance implementation of 3D games. So iOS design themes look like this. So actually sort of every Apple platform has some design themes. And for iOS they are clarity, deference, and depth. Which sort of means is actually what we've seen in the screenshots, supple decorations and focus on functionality. Not a lot of decoration, and of course this also means like legible text and high contrast, because if you're using your phone on the go in direct sunlight, it's much more likely that you're able to read stuff that is on it if the text is, say, black on white instead of dark brown on dark blue. Then again, deference, which sort of means, hey, use the actually quite small screen and do not even add more frames and borders and bezels around it. Just put content in sort of full screen to actually just make the user show the content instead of losing even more space, and then sort of make the actually interaction enjoyable by putting the focus on the content, by making it very interactive. Like if you're having an image or something, let the user be able to touch on it and wiggle on it and something should happen. So what you therefore often see in iOS applications is if you have a table and some image on top of it, the image will sort of stretch and shrink when the user scrolls through the table to just make things, yeah, feel more interactive. This is also the overshooting that you see when you're having a table. You can scroll, basically continue scrolling and scrolling and scrolling even if there's no more content. And it's quite elastic, so the contents will scroll up and the moment you lift your finger again, they will jump back. This is just to create the illusion that actually the content is always coupled to the finger. Not like on Android, where when you've reached the end of a list and you're scrolling, just this half circular blue shape comes. And this is the moment where suddenly you feel stuck because you moved your table and the text was always moving with your finger and suddenly it stops. And this feels very decoupling. And then lastly, depth, which is basically the keyword for sort of creating hierarchy and make it more comprehensible how your user interface is stacked, where basically views appeared from and in which direction you can close them again. Now, in contrast, if you had a look at the macOS design themes, they are like expansive, flexible, focused. So it's really like, oh yeah, we have a large screen, applications are expensive, I can add a toolbar here or a toolbar there and a menu here and another pop-up menu there. This is not what you have on iOS. So iOS focused on the key features and highly interactive. But let us go back to what we had earlier. If you have a look at just this Cocoa layer that is running on the Mac, and thinking about the MVC paradigm that we have to implement it, we realized the following. Our model takes advantage of Foundation and probably Core Data. But actually, on our view, which is platform native, takes advantage of AppKit. Also, our controller, like the View controller, uses AppKit. And what does this mean for reusability? So if I have an iPhone now here, where Cocoa Touch is basically quite similar to Cocoa, it just replaced AppKit with UIKit. This means I can share my model. But neither the views nor the View controllers can be reused. So I have to re-implement everything. And as we all know in this MVC structure, the controller has to do a lot of code. So of course you can still then refactor some of them, shared logic, and add it in some extra object, so you add another abstraction layer there or put some more knowledge in the model. But this is still a lot of work to implement. And this was sort of the motivation which made Apple create some new UI framework. And this is SwiftUI. So SwiftUI basically goes away from saying, oh yeah, I have all this imperative code, I nicely tweaked my table on my phone, and now I have to do everything again for the Mac. Instead, it works declaratively. Like in this example, we see an app that has some title. The title is displayed here on the phone or in this pop-up menu window on the Mac or even here on the watch. And then I have some options that I want to do, like in the case here, I have toggles, switches, and then they are translated onto checkboxes on the Mac. They aren't there. And then sometimes I want to select an item from a list. So on the Mac, this is typically done with pop-up boxes, except if there's only like 2 or 3 items in this list. In this case, I would take a radio button group. For iOS, I would instead just have them appear there. Users would click on them, a new screen appears, then they select from the list, tap on an item, the list closes again, and then they are back in the screen. Now, the interesting part about this, that both the radio group and this list here is called a picker in SwiftUI, because actually now the framework decides on how to use it or how to interpret what you want and put this into a fashion that sort of matches the human interface guidelines for every platform. And this is actually quite interesting, because if you have, say, a picker on iOS, this is typically this round cylinder that shows you lines of data, and then you scroll to them and they all rotate around. I think you've all seen them again sometime. And now if I put a picker into a table, it will sort of change what the picker does, and then it turns into a list that appears, a linear list, just like a regular table when I tap on it. So SwiftUI knows basically best for me what I want to do. So yeah, SwiftUI, unified framework across all Apple platforms, declarative instead of imperative code, quite interesting, but of course you're losing customizability with this, right? I told the system I want to have a picker and this is all working and I don't even have to write code that binds the selection, but I can't really say, yeah, but I wanted it to look differently. If I wanted to look differently, I would then have to add more code, like to the iOS code base and more code to the macOS code base, and they actually all the benefit of sharing the code would be gone again. But there's sort of another advantage, that it sort of brings back bindings into our code. And actually what I also find quite interesting is that there's not a specific UIDL, but actually Swift is the UIDL. So if you have this example here, this is just a list of rooms. Quite a simple app. If you had to do this, say, in UIKit, you would implement your view controller, you would nest it into a navigation controller, you would say, dear view controller, you are a table view delegate and data source, then you would sort of have a look into the model, provide the number of sections and rows and so on, and then fill your cell every time for each cell. So it's like table view, cell for a row at index path, and then let my room is room at index blah blah blah, index path point dot index path dot row, and then you would set the text values of these different labels. So yeah, it's like 60 lines of boilerplate code, right? With a SwiftUI, this is different. So what we see now here, actually the first thing is views are no longer objects, they are structures. They are more lightweight. This also means we create them and then we throw them away again if we don't need them anymore, which also means that we're going away from MVC, but instead adapting model view view model as our new paradigm, so that we have a new view model in which we bind that has all the application logic, and then a view is just some structure that appears and disappears, so it's very more transient. And then every view in SwiftUI has a body. A body is basically its content. So you see this, it looks quite weird, which means it's a closure. And what does this thing do? Basically, let's start somewhere in the middle. We want to define a cell that's sort of an image and 2 labels. This is what we see sort of here. We have 2 text labels that are already bound, like room name and room capacity. and then put them then into a vertical stack. Then we're adding an image next to it, and then we're putting this into a navigation button. A navigation button basically means, actually I'm a horizontal stack, but if a click occurs in it, something new happens. And in this case, I would allocate a new detail view, basically structure, for this room. Then I'm going to put this all into a list, and then I put this into a navigation view. And boom, my UI is done and ready, and it's working. I defined an action, I defined the way it looks like, and all in this code, and also with a live preview. So this looks pretty great. Of course, you're losing customizability. In the end, all your SwiftUI apps sort of look like a settings app, of course. But it gives you so much. Like, you can now bind your UI to a state. If you could say, if I have a state that it says network available, then I could just say, dear navigation view, and I would add another modifier view here. If the network is not available, please make everything grayed out, and it would work. So this is also maybe an interesting point, because the notation here is quite interesting. We see I'm creating an image of this image that the room provides me. And then I chain a parameter here, like dot corner radius 8. I want it to be rounded. And of course, I can chain more and more parameters there. Like for the text, I can select the font, I can select the foreground color. I'm only going to pick between secondary in this case, because actually with the introduction of dark mode, sometimes colors toggle and then black becomes white and so on. So it's not good to use hard-coded color here. But the interesting thing is that we have this dot notation. Now, you might argue, oh yeah, I can imagine how this is implemented. I have a text view, and the text view has the method font, which means when I implement this, this is basically like a setter method that then returns the same text view again and then defines a foreground color. And again, this is like a setter. So it's like a setter and a setter and a setter. The answer is no, this is not what it is doing. Instead, what happens here is we have a text view, and then we put this into a modifier view, and this modifier view will make all the contents that are in this modifier view to have the font subheadline. And then again, everything that is in this foreground color view will have the secondary color. So actually now we have a view in a view in a view. And what then happens is the framework, before it renders it everything on screen, compresses this into a single view. But of course, this means I can nest things. And this is actually important if you have a look at, say, the way things are padded, or if there's a background color. Like, I mean, sometimes you don't really know, or the order matters. Is the padding applied before you change the background color? Like, if you give your word a background color, this background color would cover the whole word. And if you then add a padding, this would be outside this box. If you add a padding around the word and then apply a background color, then suddenly the background color covers also the area of the padding. So order matters in this case, and this was probably the only way to go for it. It's not quite obvious, but in the end I think it's a quite interesting framework. I don't know whether it's ready for prime time yet. I guess no. Yeah.
Just to be sure, it lives or it resides beside the other UI case, right? It doesn't replace the other one.
Not yet, yeah.
So they seem to want to replace the other one with that.
Again, recurring pattern, history repeats itself. So will it replace Cocoa or UIKit? Yeah, sure, at some point. But this only works in Swift, not in Objective-C and C. A lot of the old code base is there. And then think about Carbon, Apple's sort of technology that was supposed to be a bridging technology. procedural API inspired by the Mac toolbox from the old classic Mac systems, but running on Mac OS X. And it lived for 12 years until it was finally deprecated. And then you were still able to execute these apps. So expect this to take another 10 to 12 years until this is the way to go. Maybe for some things, it's definitely already easier. Like if you have a form, you don't have to bind the stuff. Like username and password text field, you don't have to bind this into what you save. You can directly put an action somewhere there. You can even put the check, like, is the password long enough, and bind this to the selection state of or whether the button is available or not. So there are a lot of advantages there. You can even, and I mean, in the end, this thing has to live inside iOS. So actually what the root Swift view does, it creates a UI view representable. So it actually sort of returns a UI view that then lives in UIKit, because in the end, the rest of the framework is still UIKit as well.
So you can combine.
You can combine them. Yeah, and of course, there are still more additions to AppKit and UIKit. So they are not dead. They are far from dead. This is a new approach. And of course, it takes some time until they are feature equivalent. Currently, they aren't. So it's just to show you new directions. And I think actually interesting here is being maybe that the UIDL is already the language in which you implement stuff. Like if you think about QML in Qt Quick, there was QML, and QML could execute things, but you couldn't implement your whole application like in this JavaScript fashion style into a QML. It doesn't work. So in the end, you would still connect it to regular C++ code. Here, it's actually the language that we're using for the implementation of our model of the app logic of everything is the same. It's all Swift. And then together with the declarative fashion and the interesting approach of chaining stuff, putting it into a substructure. This is probably also the reason why they went with structures, because now for this small label here, the subheading that we have here in every cell, we sort of created 3 structures and then compressed them into one. And if we did that with objects, it would be way more heavier on the memory. So next part, Android. So we said mobile systems are typically an app-centric environment. Yeah, that's definitely also true for Android. Actually, it's more like an activity-centric environment in which we share components across the whole systems of different apps. And we will see what this means. But again, let's start with some history. So Android history for us starts in 2007. There was sort of the prototype of the very first Android device, and actually it was pretty much inspired by BlackBerry or Palm device, which means no touchscreen, a QWERTY keyboard, and then some joystick under the display with which you navigate through the device. So, as I said, BlackBerry style. And then the iPhone came out, and suddenly Android devices became touchscreens. Yeah, coincidence. But what you see here, and actually just something that you still realize when you're developing your Android application. Of course, the software for this device had some assumptions, like how does a typical BlackBerry app look like, or dumb phone app look like? Well, usually the most important thing is probably the address book. So it's quite a good idea to have a lot of different labels for my address book. And this is something that we have in Android. There's the address field label, the phone number label, the email label, the name label, the birthday label, and some other labels. They are all the same, but there are sort of formats for things that we typically find in an address book, because yeah, this is what originally the developers thought they would be developing for. Of course, then, yeah, things changed. First Android device here, the HTC Dream touchscreen, still a QWERTY keyboard, but yeah. Then a year after the App Store, the Android Market, same advantage, finally able to put apps there, install them, and have a higher integration than just a website. Then 1 year after the iPad, support for tablets, and 2 years after Siri came OK Google. So far, very similar. 2014, so again, sort of matching with the Apple Watch, the support for TV and watches. And then finally, like some unique ideas like fingerprint gestures in 2015. They sort of allow you to have basically back-of-device interaction. So a lot of Android devices during this time, but still have fingerprint sensors on the back of the device, and then you can actually use them to say your swipe over the sensor while the device is running, to maybe for a shortcut, to open your phone app or to access the camera, for sharing, seeing notifications. There's a lot of possibilities there. So how does the Android stack look like? Well, it also sort of starts with Linux kernel, so basically very similar to iOS. That sort of creates drivers, allows you to have shared memory and power management, USB, Wi-Fi, sockets, whatever. On top of it comes a hardware abstraction layer, so even more drivers basically, again implemented natively, say in C, for audio, Bluetooth, camera, and so on. And then we add more to it, like native libraries. We are slowly adding stuff there, like WebKit, so basically the Apple-founded open source web implementation there, FreeType for fonts, OpenGL, SQLite for databases, SSL, and so on. And this also already sort of closes the number of things that are available in Android that are implemented natively, say on C, C++. And then the native libraries basically are bundled again as core libraries, which are then basically the Java wrappers for the native libraries that use everything on top of it, and so the Android runtime system. So, and now this is the point where we start to implement stuff in Java or Kotlin. Then we add stuff on top of it, so things that are specific about Android, content providers, activities, resources, and so on. We will see them later. And then finally, the applications, of course, running on top of them, like an ARM browser, whatever, or even your own custom app. So I said that the idea of Android is to share elements of applications. This also means there's actually not a single entry point. And you already, if you hear that and think about it, it makes sense that, say, the app bar, a thing that very looks I think by default blue bar on top of your app under status bar, is recreated for every single activity, because you don't know how you entered this activity. On iOS, on the other hand, where typically the format in which you reach a view controller is sort of defined as a path through your own app, this is not needed. And then you find 4 types of components that can be entry points for your applications, and these are activities, services, broadcast receivers, and content providers. An activity is basically a visible screen on your app, and then services, broadcast receivers, things that happen behind the scenes, and then lastly content providers as a more streamlined way to access your, say, your database and provide sanity checks before you save data into your data store. So let's start with the activity. As I said, single screen of your application's UI. It contains the view of trees like the dynamic widget hierarchy. It also defines menus. It can start and stop services, and it can call other activities via intents. So we've seen for Swift UI, we just allocate a new struct that defines the new view and then tell our navigation button to go there. If you're using UIKit, you have the storyboard, you have the segue, you tell them, oh yeah, go to this screen. And for the activity, we do this, or for in the Android world, we do this with an intent. So an intent is then this messaging object that requests an action from another app or your own app. You don't know. This is the difference basically between explicit and implicit intents. So if an intent is explicit, it just means, oh yeah, go to screen B in my own view, in my own app, I'm sorry. But an implicit intent is also possible because the idea of Android was to share activities. So I can just say, oh yeah, I want to call somebody. Is there any app that can call a person? So if I'm here in my Google Maps thing and I'm pressing this call button, I'm creating an implicit intent that says like, please call somebody with this number, and then the new activity appears and I'm in the phone app. So actually it's whether this was successful or not, like say you want to let the user select an image. You click on this button that tells you, dear intent, please show me your image library to select a photo. It will happen. User taps on it, and the return value will come back to your activity. And lastly, then the worth to mention, the intent filters expose the functionality that you want to offer to other apps if you sort of want to participate in this network of implicit intents. We said there was more than just the activity, namely the broadcast service and broadcast receiver service and content providers as well. So what is a broadcast receiver? Broadcasts are in general implicit intents. As I said, say the Google Maps app says, I want to call somebody, here's the number, and it hopes somebody will react. And of course there are other events like the device shuts down or the battery is low, there's an incoming call, the time zone changes, whatever. And you can also react to these events. Now you would argue, yeah, this is quite similar to what I know from, say, iOS or macOS. I can listen to what is going on in the notification center, and if this thing says incoming call, I can do something. The point is, this is the basically dynamic part, that you can react to changes in these things during application runtime. But Android also allows you to create static broadcast receivers. These are apps that start when they listen to a specific broadcast. So this means if you listen to the implicit intent of device shutdown, you could actually implement a static broadcast receiver that shows, say, an advertisement alert every time the user wants to shut down this device. So this is sort of the reason why, of course, the Google Play Store also has rules and people who check what the developers do and try to put into the store, because this is, of course, also an area for bad behavior or malicious apps, basically. But in the end, it's quite cool that you can sort of wake up your app from the outside world just by reacting to an event that occurs from the system. So then a service, and wall of text, I'm sorry. A service is then a long-running operation in the background, like playing your music or whatever. So say you're implementing a music app and you want to play back music. In this case, the music should probably continue playing back even when the user closes your app. And this is what you would call an unbound service. So your player activity creates the service that plays the music, and the music is playing unless our activity is basically done. And our activity is never done because it always has a new song. But there are also things like bounded services. Again, we expose functionalities to others. Then elements bind to our service, and then our service becomes a server where the elements are clients and bind to them. And then this service is kept alive as long as somebody is interested in us. So again, bounded service, a functionality that is something that sort of escapes the boundaries of a single app. So not very iOS-like, something that's sort of specific to Android. Yeah, and then I said content providers. Say you have an application that contains your SQLite database. So you have some data, then you implement a content provider that interacts with this database and sort of creates the queries, updates and saves stuff, and so on. So of course it manages the cursor. If you want to go through some data, what is the current item that my table should display? But it can also work with other things your app exposes, like maybe you have a widget, like not UITK widget, but a widget on the home screen, something like this, or how do you integrate into the device search. So this means then that the content providers help your application to manage and access the data, because they can do sanity checks, they encapsulate data stuff. You don't really combine this. You have a better decoupling of your activities and your data. If your data is only used in one app, you don't really have to use a content provider. But if you say, this is my app and other apps should also use my data, then you definitely have to implement the content provider, because they define the interface of how other apps can access data that is stored in your app. And of course, then your content provider always does this, the sanity checks, security checks, whatever, whether you actually want to save things that the other app requested from your database. Again, very different to iOS. If you think about there, maybe we use a core data model, then the code, basically like the content provider, is sort of largely generated and app specific. The files that represent the objects in my database are also generated, and they aren't shared with other applications. One other thing that you find in an Android app when you develop them or when you create your empty project is the manifest file. And this is just an XML file. So very similar, like say the plist, or also something that like in the manifest in the Windows app. So it's a black box view of your app. It provides the interface to the OS and tells your Android device how the icon should look like, whether it needs specific permissions, and whether it can actually run on your device based on specific requirements. And then, of course, all your functionality has to be in there, like intent filters and available activities, because the OS has to know which activities can it launch in your app. What are the different starting points that your app provides? What can you do with it? One thing that is quite interesting, and that is definitely very much different from iOS, is the concept of tasks and multitasking that arise because you have multiple points of entry into your app. Like say you are an iOS app and you show a map. You want to share this map position with some other person via email. In this case, you would be in your view controller, you press on the button, and then the Mail app, the Apple Mail app, would provide you some view controller that you embed into your own view hierarchy, which means that even though the view controller for writing your email inside your own app comes from Apple Mail, you're still inside your own app. You're still inside this single app that lives concurrent by all the other apps and for which we scroll in the task switcher. For Android, this means we are opening up the email app. And now, say Gmail has an own screen, and then the Gmail screen comes on top of your screen. And of course, there are different workflows possible in which you're saying in an app, you're implementing a new Snapchat edition. And you're in Snapchat. And then, no, better probably you're in your app. You are in your app. You press on select photo. You are then in the photo library application of your Android device. You select a photo. You are back in your app. You are editing the filter, and then you're probably putting this into Snapchat. You are switching actually the apps, and if you go back, you sort of go back into your app, back into the image gallery, and so on and so forth. So there's way more intertwined behavior there. And this means that actually we have something that's called a task. And a task is a sequence of activities that can be from different applications. Like if I have an audio guide that just has a main screen and a content screen, I would not have different apps in there. But if I have my Snapchat example, there would be different apps all in one task. And then every time a new activity is started, based on an intent, the previous one is moved to a backstack. We are showing a new one. Typically, they are always sliding up vertically, and we are in this new activity. What you will also see is that you can instantiate the same activity multiple times in the same backstack. So this is possible by, again, in our Snapchat example, we do a filter and then we go back to the, maybe we want to add another image onto our previously selected image. We would go back to the image gallery and add another image on this, something like this. And the back button, this thing that you typically see somewhere there on the screen, maybe it's a hardware button, who knows, switches then to the previous activity. When the user presses the home button, like the middle one, this signals that the user is sort of done doing a new task, and then we switch to a new task. Which then also means that by doing this, and what defines a task, say editing one document is a task, this means like if you're using Google Docs, you might have multiple Google Docs in your app switcher that show different files, because the task is about the file and not the app. So that's conceptually also different from iOS. With this comes a very interesting take on back navigation. So this here is my virtual Android device, and I have this app here. It's called Sheep. I press on this button, and now I'm in the list of in this activity, my sheep, the root view activity of my application. Now I say, oh yeah, I want to have more information about Betty. I tap on her, and now I'm on this screen. So far, so good. This is forwards navigation. Very clear, just like an iOS. Well, for backwards, things are actually not very different as well. If we click on these buttons here, we are moving to the previous screen, like from this to there, from this to there. There's also another button you see there. It's called the up button, not the back button or something like this. It's the up button. But this also brings me to the previous screen, because this is sort of the parent screen of this. Right. So not very complicated. Now, I want more. My app now also exposes more things. Maybe I have some widget that provides a deep link that allows the Android system to tell, oh, I'm reacting to an intent called something like open sheep detail with name. In this case, my app could directly launch into a specific screen. So let's add my deep link button there. See? And if I click on this, I would directly jump into this screen. That's the purpose of a deep link. Say, if I'm in the website, maybe I have a website that sort of corresponds to my app, and then I can press on this website, open an app, I'm directly there. Nice. Now, what happens when I press on back? Question time. What happens when I press on back? I want to do this a little bit more interactive. We have so many Android users here. Which screen appears? This was a deep link. Say this could be any place, like a website or whatever. I've done this knowing that it is a deep link. What happens? Yeah.
It shows the root of the application.
Exactly. It shows the root of the application because a deep link always sort of inserts a synthetic path into this app. Like if the user actually opened this app, like came from there to there and then to there. Yeah. So we see this up button and the back button, they sort of do the same thing. They don't always bring you to the previous activity, but rather to something that is sort of the parent activity. This is what you would expect. So in the S1 we mentioned conceptual models, and so now with the examples we've seen, they are the users, they all have their mental models, but in general it's like the up button and the back button. They bring me back, that's fine. Sometimes they bring me back to different screens, but this is okay. But actually the designer, the developers of the Android system, they had something different in mind, and up equals back is not the case. So the app button, which is this, the up button, which is this on-screen back button in the top left corner, typically brings you to a statically defined parent activity. Of course, you could also implement it in a way that it just deletes the current activity and goes to the previous one. But the way the guidelines say it, it's a statically defined parent activity. And it never exits the app, hence it doesn't exist on the main screen of it. We've also seen this. This My screen, My Sheep screen didn't have some button there. It had a hamburger menu instead. For tasks that remain in one app, up and back behave absolutely identical because there weren't different activities and apps involved in my task. But pressing the up button is creating a new task if the current activity was presented from an activity of a different app. And this is quite crucial. So what does this mean? So we've already seen this navigation here. This is all quite clear. Let's press this share button. That brings me into the email composition screen. So what happens if I press back on my email composition screen? Yeah.
You go back to the sheet details page.
Exactly. Now, bonus question. What happens when I press this button over there, the up button? Come on, it can't be that hard. Yeah.
I'm guessing go to the screen before in the email application. So not
Exactly. You go to the root of the email application. This has never been part of my task, but why is this the case? Maybe one more. What happens if I press back on this screen here? It brings me back to the home screen. So yeah, I've pressed one time the wrong back, and now back brings me to the home screen. Why? Quite simple. I created a task when I was in my Sheep app, and then I was in the detailed Sheep page, then I was in the email composition. By pressing the up button here, I indicated the Android system, no, I'm done. Instead of doing Sheep will now be on my back stack. I'm now more interested in doing email, which means this is now sort of the root of my new task. And then going back brings me to the home screen. Yeah. Of course, this is different to our deep link example because the deep links do not contain a task switch. That's sort of the difference. Deep links, no task switch. This is a task switch. Weird. Yeah. So I think this is a nice example again where we see that things that look very good from a computer scientist point of view do not always make sense for the user. And of course, I'm quite biased because I'm used to this button bringing me back to the previous screen, but honestly, even with the explanation of the tasks, I don't really understand this. I mean, why is it a back button when it doesn't bring me back? And why does this thing lead me to the home screen? And things become better, of course, I think, with the next version of Android. These screens here like this and that will no longer expose a back button. So at least you're no longer surprised. So you've pressed the wrong back button in the compose screen, and then you're there and you realize, oh, I can't go back now, which means, oh yeah, crap, I did something wrong, but at least this is no longer unexpected. And I think the problem is actually not that this concept is the way it is, but when you switch to another task, the tasks that were currently going on are divided into apps again. So if you have a task that contains two apps, like the Sheep app and the Mail app, the multitasking overview of the app will now show the Sheep app in this screen, because now it forgot about that screen. Because this is part of the Mail screen, but Mail told Android it doesn't want to appear multiple times in the app switches, so now it's gone, and then I'm in the screen. Yeah.
Question. That was my question.
Yeah. Yeah, because of course, this wouldn't be great if I now press the app switcher and have a look at what is going on. Actually, I think it's called the task overview. I'm not exactly sure. I would have two email apps there. This wouldn't make much sense. That's why if I'm now going into the app switcher, I have the Sheep app, this screen vanished, and yeah. If I would not do this, like let's do this, then we will usually have two apps then, like the Sheep app and the email app, because they were both open and then they are both in the app switcher. Yeah. So far, back navigation. And of course, my advice, don't break it. If you're doing an Android app, this is not an iOS app. I don't know whether users expect it to work like this, but at least this is the default behavior, so do it like that. So, one last part. Making the screens bigger, designing for the big screen. Now, there is a person sitting behind the TV. Maybe if the light wasn't too bright, I don't know. We've seen that actually this idea of having apps became very prominent. And we sort of see, of course, companies doing apps for everything, even though we didn't really need them. But apps are a big business. So, of course, we want to bring apps from a commercial point of view to TVs and other devices. But, of course, they are also interesting from an HCI point of view. Not because, like, we know what a TV is, but we sort of create unified interfaces across different platforms for different experiences. And input on a TV is, of course, different. I have different input devices. I cannot just go to my TV and touch it. And also, what is the right amount of information on a TV? I mean, it's a large screen. But actually, if you think about it, the pixels are also quite large. The resolution isn't that high in comparison to a smartphone. So also you cannot put small text on it. It won't look crisp. Also, the user is sitting far away, so he cannot even see small text anyways. So if you have a look like at TV toolkits, say tvOS, or going back to the Microsoft platform, the Xbox One, we will find, again, 3 design teams for the TV. And the first one is that doing stuff for the TV should be immersive. You should engulf people in a cinematic experience. You should exploit this large canvas. People sort of want their TV to be filled. It just looks better then. And then because this is a very visual thing, a TV, use fluid animations, captivating audio, vibrant colors. We sort of expect there to be transition sounds, and you will see them, that they are both on, say, Xbox and Apple TV, that everything moves very nicely and dramatic, because this is sort of the experience that we expect from a TV. And I guess I'm going to flip all these the color schemes for these slides so that you see more. So, better? Yeah. Okay. The other thing is that the interaction should be clear, use consistent layouts, and make the focus clear. Like, which item is selected? Is this clear in this screenshot? No. What happens when I press the OK button? I don't know. Is there something highlighted? No, it isn't. So make the focus clear. Not a good example for this. Typically, once something is highlighted in this menu, it will appear larger than the other ones in tvOS. And it will be very sensitive to movement. So if you move something on your touchpad there that is on this Apple TV remote, these things will wiggle accordingly to your finger input. So you see them. On the Xbox, on the other hand, there is a glowing, colorful halo around the currently selected or focused button. So you also see directly what is going on. And then, of course, movement across space is consistent and predictable. What happens if I slide to the right side? Of course, I want to go to the right side. So if I swipe or press the right button, move my joystick to the right side, say I'm switching from there to there to there to there. Obviously. What happens when I have a full screen image? Now suddenly this mapping changes. Like if I have a touch interface that's providing input, to scroll to a full screen image, I'd rather have the image follow the content, the image follow my movement. So if you think about your smartphone, if you zoomed into an image, you drag your finger, then the content follows the input. So content should follow input if you're in full screen content, and then the controls should follow the direction of the input. This is a little different thing. And then lastly, the third stream is basically across the room. Users sit there a few meters away from it. Maybe they are cooking while watching it because they have a video that helps them to prepare some recipe. This also means that resolution and viewing distance make it difficult to process too much information on it. And as a rule of thumb, just use as many information on your TV interface as you have on a phone interface. And then sort of connect the user with the content. So this is sort of the example, like this should not be a screen that is sort of sitting there and I'm looking at it sometimes, but the user should sort of have a relationship with it. Actually, this is something that we want to have with every product nowadays. That's why we have taptic engines in, say, an iPhone that are vibrating a little when you press a button and so on, so that it feels more natural. And of course, this haptic output is always a very more intimate, more private connection to the device. And how do we connect in this case for the TV is then we have, say, a remote that can detect continuous movements in the air or voice commands. So example is Siri remote, something like this. So I already said these are our input devices. For example, like a regular remote, an Xbox controller, and of course, because even Microsoft knew controllers aren't that great if you want to consume media on it, so there's even an additional Xbox remote with buttons. But, yeah. So what we see here is then for the Apple TV remote, there is no sort of a D-pad. Instead, we do gestures on this touch screen, move along this thing. Of course, this means different types of input. And then for the gaming controller, it's quite clear we always want to use the D-pads for interaction. So as I already said, the selected item has to be very clear. in which state is the UI? What will happen when I press the A button or click on OK? And we will see that the interaction with TV UIs is always based on the focus model. There is always one element highlighted. The TVOS example, the selected item even is more sensitive to the input of the remote. I already mentioned to always move the focus in the expected direction and to make the focused item obvious. So how does a focus model look like? Like, see, this is a button. This looks very Xboxy. See, it's highlighted and has a colorful shadow. Now, the focus model takes an internal picture of your UI, and then it considers all visible focusable views that are somewhere there. And then say I want to move now to the right by pressing the right button. Basically, this channel here, this conduit appears, and we will see we are landing in this view, and we'll update our focus. Of course, the size of the surge that you have for the next possible view is sort of defined by the height of this button that is here. So if there are smaller buttons, it will probably take the first one. If there are a few sitting here and the layout is not exactly on one line, it will take the closest one, and so on. So this is all great. We've seen we can go from this thing to there, up and down, and so on. But what happens if I do this button there? Where's the problem with the focus model? Come on, interaction. Why is this button a problem for a focus model? It always takes, sort of looks at its, in this case, height or width, and then checks what is coming from there, from there, from there. So this middle thing is never in the path of any of these views. It can't be reached. And of course, we now don't want to limit ourselves to not being able to create user interfaces where the buttons are not always sort of reachable by this model. So we have to do something to make them reachable. And this is sort of implemented in two different ways. Again, there's the imperative approach and the declarative approach. We will see both of them. So we said some UI elements are not accessible by the focus model, and then we have to fix this. And the possible solutions for this would be either to statically define the successor of an item, or by adding even more layout guides that check whether some check appears along one axis and then reroute the event basically to another button. Let's first have a look at tvOS. So you see this is a mock-up screenshot of an app that allows you to shop in a more immersive way. You see, currently you can buy here Lorem Ipsum, and the selected item is already Shop Now. But there's a More Images button in this image. The problem is, again, I can't reach it. There is no way to go up or down or left or right or whatever to reach this thing. So what we do now is we add layout guides. These are basically like invisible views that occur in the channel of one button here. So if I would now go down, this thing would find the layout guide and reroute the input to this button. You were looking so irritated. Yeah, it's like there's a button, and it reroutes things.
But is it like an additional button, or is it just movement?
It's invisible. It's like a view. So remember this example here. So we go from this view to there by going to the right, and we only find it because we check whether there's another view appearing at some further x coordinate in this direction, in this area, like there. Then we take the first one. But if a button is not reachable from any of these, we can't find it. So what we would now do is place a layout guide, say, somewhere at this position, that would then reroute the event to this thing. And then every time the user clicks to the left, the event is rerouted down to this button. This is just like, imagine this is a laser beam, then you have a mirror that is angled with 45 degrees, and then the laser beam would hit this.
There's problems with going back to the previous selection.
Yeah, of course. Now the back direction is still not implemented. You also have to add one more here. Yeah, we will see this. So, so the code for this, like I'm implementing this thing, would be to this, would be that. I create a focus guide. This is all this code. I use auto layout to constrain it to its position between these two other buttons. And then I have some focus guide. And now if there's this delegate method, did update focus, blah, blah, blah. And then I can set a new preferred focus environment and tell it, oh, if this hits me, say the next preferred focus environment is, say, the shopping button or the more button or whatever. Which means I have to write code here imperatively, and this part is already only code for the for one of them. Like so far, I've only did this. I also have to write 8 more lines of code for this thing here. But then my UI would be flexible enough that no matter whether I now press left or down, I would reach this button, and again up and right will reach this button again. Clearer? Yeah.
Yes. What happens if we have like 4 buttons in the 4 corners? How
Yeah.
would we then implement the reaching of the middle button?
So you said if I have the 4 buttons here, 2, 3, 4, and now I have this one. Now it becomes ugly. I have to implement one thing that reroutes it there. Actually, I would just do it like this. One thing that reroutes it down there. I would add 2 more that reroute stuff from there and there. No. Actually, this is not very good, right? Because if I do this, I cannot no longer reach that one. So probably you would have to decide on something. Say, this button here is button A. If I press down, then you have a layout guide here. You reach this. If you press down now again, you would add some layout guide again here. That goes there. Then you have the 3rd button. And you would let the others impact free. So going then from there is still regular, and this is also still the usual way. So of course, if you're not specified, this also means now your middle button is only accessible from a certain button, from a certain other button. So it's a problem. I mean, technically it's possible, but of course, this is not always unambiguous what happens. And of course, it's invisible. You don't know what happens. So the 5-button design is actually never a good idea. You could probably, what would be the best thing would be, oh, we can't wipe it. Oh, we can. The best design would then probably, if you have the 5 buttons, 1, 2, 3, 4, 5. Say, for me, these are like 3 columns. And then you say, every time the user presses the right button, he reaches them. See? And then again, right, you reach probably this one. From down, you reach that. And then if you go back, no matter what, this is always possible. And then this will always lead you like that. So you would have this navigation. And this is again then more obviously definable by focus guides, because then you would add just one more here, one more there, these two, and you would be good to go. But yeah, this is so you see, not that trivial in reality. And you thought, oh yeah, I'm just going to do a UI for the TV. But it's a problem if there's not a cursor, and if I don't want to use a cursor or a touchscreen, I'm stuck and have to select on something. Now for the Xbox, a slightly different example. Say I have 4 buttons here. It lets you use a selected chapter, maybe of some audiobook or whatever. I have these buttons 1, 2, 3, 4. So this is something that of course works with the focus model. But if I'm in chapter 2 and I press the right button, I would land in chapter 4. This would again not make much sense. So what I can do now here is sort of reroute these things both into 3. And I do this by just clustering them in one higher level of control and using a binding again, a syntax that you already love, I know. So it looked like this. I have my stack panel. You see the horizontal stack panel there, and then the vertical stack panels there for button 3. Button 3 now received the title X name button 3. And then I can use this to bind my XY focus right of this group of both 1 and 2 to 3. And now every time I click on the right button, no matter in which one of them I am, because they are both a group, I will go to button 3. And the nice thing is, because I only said reroute both right directions of them to 3, the left directions are unimpacted. So from 3, left goes back to 1, and from 4, left goes back to 2. Because this is definitely more deterministic, or more what the user expects. So yeah, you see UIs on Xbox just like your other UWP apps, just another target, and same binding syntax, of course. So last pinpoint of DIS1 contents for today. In DIS1 we talked about interface efficiency. And how does this apply to a TV interface? So what you see here is, I have a mock-up screen that shows me the title of, or it shows me the details of a movie. There's a movie cover, there's the movie title. Lorem Ipsum movie is apparently rated R, okay, and it's an action movie, I always knew that. And it has good ratings. You see there are some probably most important buttons. There's a play button, which is currently selected. I mean, we should always make the selection clear, you know. And then there's download, delete, share, whatever. Then there's some text. Apparently this text is quite large, so it's truncated. We have to click on it in order to expand it. And then there are more episodes of this movie, and I can select them. Now, what could be done better with this UI? Why is this UI not optimal? Imagine this to be the default location where the play button or the focus is. The focus is on the play button. This is already a good thing, because probably in 80% or 90% of the all possible interactions that people do, the play button is directly called. What would be the other things? Skipping to the next episode? Or reading and then playing? So why is this thing not good? What would we have to reorder to make this UI better?
maybe previously the selection of the episodes, because I'm already currently in the middle of the series.
Yeah. But now you would have to navigate to the play. Like you're standing there and then I have to press up. Then I'm here. Then I press up again. Now I'm at delete. Now I press left. Now I press left. Now I'm at play. No, play, focus on play should not be changed. Focus on play is definitely the most important thing there. But this is already fulfilled. It's about rearranging.
Yeah. Changing the text and some more episodes, because if I'm selecting a movie, maybe I want to select another episode.
This is already a good direction. So if I switch that, the access to the more episodes would require one less click. I like it. But now the text requires, yeah.
Well, changing the order of the text and more episodes shouldn't be the way to go, because it's depending on the user. If I'm at home and I don't know the series,
Yeah.
I want to read the text.
Exactly. So I said rearranging is already good, and putting more episodes closer to this bar. Maybe I think we have 3 components here. Yeah, but changing the order here is not the correct thing. It just is better than the current design, I would say. But it still has the same issue. What would be a better solution? It's going to be a facepalm moment, I guess. So if I just reposition the order of the buttons and the text, now more episodes is available with one click. And the text, if the user wants to read it, is again one click away, go up. So we sort of try to decrease the number of button presses the user has to enter to read something. And in this case, for a TV app, it makes a lot of sense to have the focus somewhere in the middle and then be able to go up and down to just make it faster. And because the selected item is always very obvious with size, color, and so on, it is not a problem. Users typically find immediately which item is currently selected. So the selection doesn't have to start in the top left corner. Yeah. One even worse example. So here you see an app that shows you different flats that you can rent. So you see we have a search bar and some filters for our list of homes. And this list of homes says probably it's, I don't know, maybe we found 50 houses and now it lists 50 houses. And then there's some buttons to switch between the houses that are currently displayed here in this detail view, which is also highlighted there. So you see this house is then visualized on the map and on the text. Where's the problem in this design? And I said, imagine this list to have like 50 items. I go down from here to, I just wanted to have reach these buttons. How do I reach these buttons if they are placed under the list? I would have to click through all of these 50 houses again and again and again and again until I reach this button. Again, not a good idea. How can I fix that? Yeah.
Maybe just change the buttons and put it on the side of the list.
Yeah, this would already work. It breaks the order. This would probably not be very pretty, but it would work, exactly. Maybe even putting them under there, it's previous and next, it's like left and right, but on top of each other. But as long as it's not in the same axis, everything is fine. And this is something, oh no, this slide doesn't work on. Switch back to the dark mode. And this is something that we have here as a guideline. Basically, always use different axes for navigation and content. You see this, say, on the TV app or the Netflix app or whatever, I can switch between categories by going up and down. Like, if you think about Netflix, it always has these movies in rows, because then it's action, then it's drama, then it's thriller. And I click through the categories up and down, and then left and right is used for the contents, to switch between them. So I always have sort of a minimal path. Sometimes this is not possible. For these cases, I have to lock the focus in a specific area. Think about this thing here. I have the map. Up and down is already taken. Right? Also, how can I move in this map? Probably the best idea, make it selectable, so focusable. Then I click on it, I'm in the map, and now I scroll with my D-pad or Apple TV touchpad, whatever. And then the last resort is use the cursor for contents that scroll in these two directions. Because there are things that feel very nicely when you have a D-pad, or especially when you have a touchscreen. But imagine clicking through this map, but always shifting it like one blob to the right, one blob to the right. With the D-pad, this is sort of more continuous, more easier to accelerate input. This works fine. Touchscreens works fine. D-pad, not a good idea. And then sort of think about cursors. But still, cursors with D-pads also doesn't feel good. Cursors with touchscreen doesn't feel good. So use a cursor actually for, I would say, only if you have expect your users to have a controller. Because of course the cursor has the advantage that it doesn't have the limitations of the focus model. I can just reach anything by just moving stuff to the left or to the right. And if I really am not able to create some different menu design because I have a game, then use a cursor. But only if it's really needed, because you have an inventory menu in a game that has like probably 100 possible items there. And this is the point where continuous input with the cursor is better than keep stepping through all the buttons, because cursors don't feel good in general if they're not done with the mouse, but they're still better than requiring the user to do, say, 50 or hundreds of clicks in order to achieve the target that he wants to see. So let's wrap up with the question, what's beyond smartphones and TVs? And we will just quickly mention them due to the lack of time, but of course the first thing would be a car. So in-car interaction with CarPlay from Apple or Google Auto. And CarPlay is again interesting because of two aspects, both from the technological and also the conceptual point of view. Technologically, CarPlay has basically evolved from AirPlay, Apple's streaming technology to show video from your phone to, say, your Apple TV. But of course, AirPlay is unidirectional. You stream an image, and now suddenly you receive inputs again that are queued back into your system. So the protocol had to be extended to be also two-directional. And of course, the iOS app was always assumed that there was only one UI window, one screen at a time. Well, this thing is like a second window. So now your app has two windows, and then they extended a window. Now apps can sort of check in which window the event occurred. Is it a CarPlay event? Is it an iPhone event? And of course, automakers are always very slow in adapting new technology, because actually the life cycle that they have to create a new, say, in-car entertainment system takes 3 to 5 years or even more. So at the time CarPlay was introduced a few years ago, most of the cars didn't even have touchscreen. And if they had a touchscreen, it was a resistive one instead of a capacitive one. which also means that the interaction, even though we want the interaction to be very similar across all these cars, because this is sort of the purpose in having a unified UI and UX across all cars, is to work around the technical limitations, because there's so many different ways users might want to interact with it. Buttons on a steering wheel, rotary knobs, touchscreens, capacitive or resistive, maybe just buttons in the middle console between the seats and so on. And Apple had to qualify then between different screen categories. They said, oh yeah, the best one is basically the capacitive touchscreen, and for them we will have scrolling that feels just as natural as on the iPhone. For the resistive ones, we will only scroll by touch pressing on buttons, and then it will switch to sort of the next six rows of your table view and so on. To always find an interaction that is suitable for this. And there are actually a lot of things that you will find or see when you have to try to create a software, even though they now pretty much knew what it would look like, and they were able to control the whole UI because of the various forms of hardware. Actually, there's still a lot of code that you have to consider and write to sort of adapt it to just the right category of in-car device, input device. But of course, conceptually, this is also quite interesting because the car manufacturers lose the privilege to the design UI. We have a consistent experience. Maybe nice, maybe not. Of course, on the one hand, this looks the same on every device, which is good. The icons are familiar with your iPhone, this is also good. But on the other hand, this doesn't really look like the VW interface of the rest of the Golf. So, yeah, this is something, this is a trade-off to make there. We see that more and more cars sort of are equipped with this technology. I think this is also quite an interesting path to continue. And then lastly, of course, wearables. I mean, these watches with all these tiny processors and memory are even more restrictive in terms of memory. There's even a smaller screen size. What can you display there? And even if you don't have resources, what can you compute on this thing? And then, again, there is this technical challenge, and we'll see history always repeats itself. Again, layout management, no auto layout, just put stuff underneath each other. Can you do fancy graphic effects? No, we have to save battery, we have to save computing power and so on. So even for the target action, a button doesn't even pass itself as a parameter in watchOS. If you implement the action of a button, it's just the action of the button, no parameter called. Just to save basically working memory. And then, of course, lastly, the conceptual thing, it's a computer that people sort of attach to their bodies. So there has to be an advantage in having this technology sort of so strongly connected to the user. So again, interesting field for HCI, and definitely we will see a lot of things coming up in the next couple of years, because I think for types of the watch, it slowly matures. We are now at a point where at least you can do something with the CPU in there, and also I think Apple itself somehow now found a way what they want to do with the watch, that it's sort of a health and fitness accessory, and yeah, we will see what's going on there. So yeah, why was this double? I don't know. Yeah, takeaway message, basically limitations repeat themselves in history, and that's why it's always so good to still look back into the old interfaces or into the old UITKs, because things come back. Even for Swift UI, we thought we were done with horizontal and vertical stacks after we've had auto layout for multiple years. And now, yeah, if you want to create a declarative system, making it in a way that the computer actually understands your declarative code, like, oh yeah, this should be leading a line, training line, this would be too complicated. So again, we're back to H and B stacks. And that's why it's so valuable, I think, to still have a look at how UATKs develop to actually understand what they do. So I think we have 5 minutes left for evaluation sheets, and then we're done.
This content was provided by RWTH Aachen University.